Hello, Math 20-1 students. So today we are moving on in our learning about rational expressions. So last time we just kind of had a little bit of an introduction to what they are, as well as how to simplify them and identifying the non-permissible values. So basically remembering that that means any values of the variables that would result in the denominator being equal to 0. So we're basically just carrying on with that. The only real extension is that we need to be able to do some different operations on them. So today we're going to look at multiplying. I've divided 6.2 into two sections. So today we'll focus on multiplying, and then in day 2 we'll look at dividing rational expressions. So just a little bit of a review from yesterday, the last lesson, the first lesson. We want to be able to simplify the expressions, and we're going to be using that a lot more today. So definitely this is a skill you want to make sure that you have figured out really well. So in this one we have 5a minus 3a plus 2 over 10, 3 minus a plus 2. So remember, what we want to do is first of all factor out anything that we can out of these two, and then simplify. So if we think about the two number values we have here, 5 we can't factor down anymore, but 10 we can factor down into 5 and 2. As for the remaining, we have a plus 2 and a plus 2. So if we look at the factors that we have now, we can cancel out 5 and 5 and a plus 2 and a plus 2, which leaves us with a minus 3 on the top. And then on the bottom, we have still the 2 from the 10. And then in brackets, we have 3 minus a. Now, in order to further simplify this, sometimes you need to just think about if you have two expressions on the top and bottom that look pretty similar, you want to think about if there's a possibility to factor something out that would make them the same. And so if you have a minus 3, you have positive a and negative 3, whereas on the bottom we have positive 3 and negative a. So if we were to factor a negative 1 out of this bottom expression, it would be the same as our top expression. So let's try doing that. So basically that means we would multiply this whole thing by, we're factoring out negative 1. So that means it gets multiplied by the 2 out here. So we end up with negative 2 on the outside. And if we've taken out negative 1 out of each of these, that means that we end up with negative 3 and positive a. So if we want to rewrite that in the same way, it's going to be a minus 3. And then on the top, we still have the a minus 3. So now we can further simplify. A minus 3 cancels out, and we're just left with the negative 2 on the bottom. But because we had a fraction here, just keep in mind a minus 3 divided by a minus 3 is actually 1. They don't just cancel out, right? So what we actually end up with is negative 1/2, right? We get the negative from the 2, but it applies to the whole fraction. And so our simplified version of this is negative 1/2. Now, in terms of stating non-permissible values, remember the rule that we need to look at all stages of the denominator. So for this one, if you had 3 minus what would give you 0, 3 minus positive 3 would give us 0. What plus 2 would add to 0. So remember, it's always kind of like just the inverse of that second number value there. So it would be negative 2. Oh, shoot, I forgot to write in a cannot equal. So let's just add that in. So when we're writing our non-permissibles, we always write the variable cannot equal. So what did we just say there? Negative 3 and... no, it wasn't negative 3, it was positive 3, 3 minus 3, and negative 2. Okay, if we look at the subsequent values that we had here, the same values would apply. So that's our final statement for our non-permissible values. A cannot equal 3 or negative 2. Moving on to what we'll be looking at today. we're going to be looking at multiplying and dividing. So today we'll look at multiplying, but just a little bit of a refresher of how you work with fractions. So keep in mind in the past when you've worked with numerical value fractions, so instead of rational expressions, what have we done for multiplying? Hopefully you can remember that with multiplication you just multiply the numbers straight across. So if we have 3 over 4 times 2 over 9, it's the same as 3 times by 2 over 4 times by 9. Okay, and so that's going to give us 6 over 36, which of course can be simplified to 6 goes into 6 once and into 36 6 times. So that's 1/6. Now, there is a way that we can kind of eliminate this middle step, which would be to write everything that we're multiplying out in its factors in the first place, so that we go straight from the multiplication to our lowest possible, like our most simplified version of the fraction. So in that case, we would write this out as 3 times by 2 over 4 is 2 times by 2, and 9 is 3 times by 3. So if we multiply all those together, we end up with, canceling out the common values, 2 and a 2 can cancel out, a 3 and a 3 can cancel out, so we're left with 1 on the top and 2 times by 3 on the bottom, which is 6. So this is what we'll be looking at more in terms of working with rational expressions. We do the factoring first so that we don't have to worry about these intermediate steps of having a more complex fraction and then dividing, because with numbers it's pretty straightforward, but when you start having longer algebraic expressions, it ends up being a little more complex. What about dividing fractions? So again, hopefully you remember kind of some of these tricks. Basically what you do when you divide fractions is dividing a fraction by a fraction is actually the same as multiplying the first fraction by the reciprocal of the second fraction. So reciprocal just means you flipped the numerator and the denominator. So basically what we would say is negative 12 over 5 times by, and we flip this, so 10 goes on the top, 9 goes on the bottom, and we end up with well, let's do that trick that we just did there with factoring. So 12, if we put it down into its simplest form, it's 4 times 3, which is 2 times 2 times 3. And 10, simplest form, is 5 times 2. So we multiply all of our top numbers together, and then on the bottom, 5 doesn't factor down. Oops. But 9 factors down into 3 times by 3. Oops, sorry, my pen is dying. 3 times by... Oh, this one's a mess. Great, okay. So now that we have everything factored out, we can cancel out similar terms, right? So we have a 5 here and a 5 there. We have a 3 there and a 3 there. And it looks like that's all we can factor out. So that means we're left with, we also don't want to forget that we had a negative value here, so maybe just keep that with your fraction. So when we simplify this down, 2 times 2 is 4, times 2 is 8. And then we just had that 3 on the bottom. Sorry, I know it's a mess, so it's hard to see. But there's our fraction that we get from that division. Okay, so with division, just remember it's the same as multiplying by the reciprocal, so you want to switch those two terms around, and then if we factor everything down, we can go straight to our simplest version of the fraction, or our reduced version. So let's look at multiplying rational expressions. Sorry guys, I'm just trying to fix this pen up here. Okay, so multiply and simplify the expression, and then the difference of course with rational expressions is that again we will be looking at the non-permissible values. So the first step to do with this would be, what I would do is find all the factors first. So first always factor before you multiply rational expressions, and then that way you'll go straight to your most simple version. So if we want to factor 12, again it's going to be 4 times 3, which is 2 times 2 times 3. And then times by a squared is a times by b. and then times by, we can just carry the whole way across. 5 doesn't factor down, times by a times by b. And then on the bottom, I'm going to use a ruler for this one because it's a little bit long. And then on the bottom we end up with 15, which can be factored down into 3 times by 5. 8 can be factored down into 2 times 2 times 2. And then b squared is b times b. Okay, so now we would want to go through and cancel out our like terms. So we have a 2 here and a 2 there, 2 here, 2 there. We have a 5 and a 5. We have a's on the top but no a's on the bottom. We have a b and a b, b and a b. So what we're left with is 3 times a times a times a. So that's, oh, sorry, actually there's a 3 on the bottom there. Whoops. So even simpler. We have a times a times a, so that's a cubed. And then on the bottom we have just the number 2. So there is our simple version. And you can see how this, when we have all the factors here, it'd be easier than first multiplying everything out, right? So it just kind of makes things a little more quick. Now in terms of non-permissible values, with this one all we have is multiplication on the bottom. So the only variable we have is b, and it's being multiplied by other things, so the only possible non-permissible value is b cannot equal 0 for that one. Okay, so that one's a little bit of a simpler one where we just have some multiplication. Now we want to get into things that have like factorable functions here. So in this first one, you can see that we have a bunch of things that we can factor into separate brackets, right? So these first two are pretty easy because they don't have an a value in front of the x, but the second two do, so we're going to have to use this swing method to factor those. So that means we're going to multiply 2 by 4 so that we have x squared plus 9x plus 8. Factoring that, two things that multiply to 8 and add to 9 would be positive 8 and positive 1, so x plus 8 and x plus 1. And then, of course, remember we did do that multiplication with the 2, so we need to divide that out. And if it divides to a whole number, we can leave it like that. So this one will be x plus 4. In this bracket, that doesn't divide to a whole number, so we need to move the 2 in front of the x and keep it as 2x plus 1. So that will be our top value. For the bottom one, same thing, we want to multiply the 3 by the 14. So we're going to have x squared minus 23x plus 42. Right, so 3 times 14 to get that 42. Two numbers that multiply to 42 and add to 23 would be 21 times 2, right? So if we have, oh, hold on a second, negative 23. Oh, and they add to positive. So if you did negative 21 times by negative 2, it would add to multiply to positive 42 and add to negative 23. So we have x minus 21, x minus 2. And then, of course, we still have to divide out that 3 that we carried through. So that gives us x minus 7, 21 over 3. And this one remains as a fraction, so we need to move the 3 out front, 3x minus 2. So now we have our top and bottom for this, and we can go ahead and multiply through. We'll have to solve for these two as well, but that is fairly easy. So two numbers that multiply to negative 7 and add to negative 6 would be negative 7 and positive 1. So x minus 7, x plus 1. Oops. Right, because negative 7 plus 1 will give us negative 6. And then divide that by two numbers that multiply to 4 and add to 5 would be positive 4 and positive 1. So x plus 1, x plus 4. And then multiplying by the values we determined here in their brackets. So we had x plus 4 on the top times by 2x plus 1. and then divide that by x minus 7, 3x minus 2. So now before we go ahead and do our multiplication, remember we want to cancel out our common factors. So here we have x minus 7, x minus 7. We have x plus 4 here and x plus 4 here. We have x plus 1 and x plus 1. And so we're left with the last two expressions there. So our final simplified fraction is going to be 2x plus 1 over 3x minus 2. And then in terms of non-permissible values, we need to look and say, okay, so for this one it's going to be -1. X cannot, I'm going to bump this down one, x cannot equal -1, -4, +7, or remember for these ones it's always the last number divided by the first one in the opposite sign, so it'd be +2/3. Of course, you can still go back and solve for these ones the way we did in the last lesson if you need to. So just keep that in mind that you do have that if you're ever uncertain of whether you've picked the correct non-permissible value for those fraction ones. All right, next one, multiply and simplify, identify all non-permissible values. So in this one, we have a bit of a different situation. We can see here we have 4c squared plus 8cd plus 4c squared. So we don't have that typical like quadratic function. But what we do have is 4c squared and 4c squared, so it's important to be able to pick out those like terms because we can actually combine those two, right? 4c squared plus 4c squared is 8c squared, and then we still have plus 8cd, and then over 8, we're multiplying that by seeing if we can factor anything out of this one. There's 3 in both terms, so let's pull that out, which leaves us with c minus d, right? If you divide 3 out of both of those terms. C squared minus d squared, remember always to keep an eye out for those perfect squares. So c squared is a perfect squared and d squared is a perfect squared. And we have that subtraction in the middle, which means that we could write this as c plus d and c minus d. Okay. So this side is completely factored now. This side, all we did was combine like terms. So we still want to make sure that we factor this one out. So for this side, 8 is common to both the terms as well as 1c. So let's pull that out, 8c. 8c multiplied by c would give us 8c squared. And 8c multiplied by d would give us 8cd, right? 8c times by d. Divide that by 8. Multiply by this side we already did, so we can just copy that out. C plus d, c minus d. Okay, and now we want to cancel out like terms. So we have c plus d here, c plus d there, c minus d, c minus d. We have an 8 and an 8. And so that looks like everything we can factor out. So in this one, remember in some of the previous examples, we had one where everything on the top canceled out. Remember that means we make it into a 1. Same thing here, if everything on the bottom cancels out, what we're left with is 3 in this one and c on that one. So that multiplies together to make 3c over 1. But of course, any value over 1 is just that value, right? Because if you divide it by 1, it is that value. So this whole thing simplifies down into 3c. Now the last thing we want to do is our NPVs. So just remember to pay attention to all parts. Now with this one we don't have to worry because we could factor that into an equivalent term. So c plus d and c minus d. So basically what you need to do here is say c plus d cannot equal 0. So if we rearrange that to isolate for c, it's c cannot equal negative d, right? We would subtract d from both sides. So that's one of our NPVs. The other one we had was c minus d could not equal 0. So if we want to solve for c, it's going to be c cannot equal, we'd have to add d to both sides. So c cannot equal d. Let's see, and that's everything. That's all of the denominators that have variables in them in the steps that we took. So that's all of our NPVs. All right, you guys have a chance to try these out for yourself. So if you want, you can pause the video, see if you can solve those ones, and the answers are listed at the bottom. But we are going to move on to, whoops, I wasn't totally thinking that through. Sorry, guys. Actually, what we will be doing today, I said at the beginning that we'd only be doing the multiplying. I forgot that I divided this up because first we're doing multiplying and dividing, but then we also have to do some more complex ones where we combine both functions. So today I'll just introduce you to the basics of both multiplying and dividing, and in the next class we'll look at some more complex operations where we combine both of them. Okay, so that's how I divided this section up into 2 days. So with dividing rational expressions, we're kind of doing the same thing. First of all, you factor. Once you have your different expressions factored, you can use 2 methods to divide them. If you had a common denominator, then you would just divide numerator 1 by numerator 2 and denominator 1 by denominator 2. Mostly we don't actually see this happening in any of the questions that we encounter in 20-1. So I mean, if you come up with it, it can be easy, but personally for me, what I would do is just remember this second one, which is where we do the same thing we looked at with just our numerical fractions at the beginning of the lesson, and I would multiply by the reciprocal. Okay, so you don't need to find a common denominator, which can kind of be tricky sometimes. Then you can cancel out any common factors like we've been doing with multiplication and state the NPVs. Okay. Now, one thing to be aware of with stating the NPVs when dividing is that no denominator can equal 0. So I've kind of mentioned that before, but with division that gets a little more tricky because you have to remember that if you had like a over b divided by c over d, and then you rearrange it to be a over b times by d over c, right? So you've flipped this so you have the reciprocal for the multiplication. Then with your NPVs, d cannot equal 0. B cannot equal 0, and B is still the same here, but also C cannot equal 0. So it's a little bit weird because it's the numerator in the first step, but the denominator in the second step. So you need to make sure that you look at both of those when you are evaluating your NPVs. Okay. All right, so in this first one here, we want to factor each numerator and denominator. So here we have x squared minus 9. Always remember with those two terms, we can be looking for a perfect square, which this is. So perfect square of x squared is going to be x. Perfect square of 9 is going to be 3. So we can make it into x minus 3x plus 3. And then on the bottom, 2 numbers that multiply to 4 and add to 5 would be plus 4 and plus 1. So x plus 4, x plus 1. On this side, so that's going to be this version factored. On this side, factoring 2 numbers that multiply to 3 and add to 4 would be x plus 3, x plus 1. And then doing our division, 2 numbers that multiply to 12 and add to 7 would be 4 and 3. So positive 4 times by positive 3 adds to 7. So x plus 4, x plus 3. Okay, now remember, because this is dividing by, we're going to have to multiply. So we're going to have to find the reciprocal of this one. So we're going to flip that in order to do our operations. So this one can stay the same. It's going to be x minus 3, x plus 3, divided by x plus 4, x plus 1. And then multiplying that by the reciprocal. So this needs to be on the top now. X plus 4, x plus 3. And we're going to divide that by the bottom here, x plus 3 and x plus 1. Okay, now we want to cancel out our common factors. So we have, let's see, x plus 3, x plus 3, x plus 4, x plus 4. Both of these are on the bottom, so we can't cancel, and then those would stay the same as well. Okay, so now multiplying this out, we're going to have x minus 3, x plus 3, over x plus 1 times by x plus 1. Okay, now when we end up with factored brackets like that, we do want to simplify it back into its function, right? So we want to multiply out the brackets. So we're going to have x times x is x squared. X times by plus 3 is plus 3x minus 3x. So remember, those middle terms always cancel out for a perfect square like this. And then we end up with negative 3 times by positive 3 is negative 9. On the bottom, we're going to have x times by x is x squared. X times by 1 is x plus 1 times x. So 1x plus 1x is 2x. And then plus 1 times by plus 1 is plus 1. So x squared plus 2x plus 1, this is our final simplified version of this. Now in terms of figuring out our NPVs, we are going to have x cannot equal, so going across here, negative 4, negative 1, negative 3, negative 1, which we already had. And keep in mind, we need to also evaluate the denominator of the expression that we had initially before we flipped it to find the reciprocal. So this one would be negative 4, which we already have, and this one would be negative 3, which we already have as well. So for that one, it was kind of easy. Okay, so those are our NPVs. Let's try one more. This is our last example for division, and then we'll be finished the lesson. So just a little bit more to tough out. All right, so c squared minus 6c minus 7. Again, just factoring that into brackets. Two numbers that multiply to make negative 7, add to negative 6 would be negative 7 plus 1, right? So c minus 7, c plus 1. The negative 7 plus the 1 will give us the negative 6, and negative 7 times by positive 1 gives us negative 7. Here we have a perfect square. Perfect square of c squared is c. Perfect square of 49 is 7. So c minus 7, c plus 7 is how we factor that out. So that's our factored version for the first expression. On this side, two numbers that multiply to 7 and add to 8. Oh, 7 plus 1, obviously. c plus 7 and c plus 1. So 7 and 1 add to 8, and they multiply to positive 7. And for this one, we can't really factor that out into brackets, of course, because this is not a perfect square. So we just need to factor out the common term, which for both of these is c. So if we pull c out of there, c squared divided by c is c. 7c divided by c is 7. So c plus 7 is what we end up with over there. Now we're going to have to flip this one to multiply it. So we can write that down here. So we have c minus 7. C plus 1, c minus 7, c plus 7. And then we're going to multiply it by flipping this. So c times by c plus 7 over c plus 7, c plus 1. Okay, so canceling out like terms, we have c plus 7 here, c plus 7 there, c plus 1 here, c plus 1 there, c minus 7, c minus 7. So the only things we have left here are c c divided by c plus 7. Okay, so c over c plus 7 is our simplified expression. And then in terms of NPVs, we're going to have C is not equal to, so to start out with here we had plus 7. Actually, I guess this one would have stayed the same, so we can look down here if we want. Negative 7. And then over here, that one would be negative 7 as well. And then when we flipped it, we still have another negative 7, but we also have a negative 1. And, oh, and the other thing we also had here was that C was being multiplied by a whole thing. So remember, anytime you have anything being multiplied, you would say it cannot equal 0. So 0 would be our last NPV there. Because if C here was a 0, it would multiply by all of this and make it 0. So those are our NPVs, and that's everything. All right, so you guys have some questions that you can try on your own, and then at the end there is an assignment out of the textbook. And next time we'll look at combining these two operations, multiplying and dividing, for more complex operations as well as for word problems. So I will see you in that lesson.